The properties of the unilateral Laplace transform are very similar to the properties of the Fourier transform. Hence, it makes sense to go through the properties and directly compare them to the properties of the Fourier transform. This is a list of some properties of the Fourier transform. Let's compare them with the properties of the Laplace transform and denote the Laplace transform of x as capital X of s and the Laplace transform of y as capital Y of s. The Laplace transform is also linear, so the Laplace transform of alpha x of t plus beta y of t is of course alpha x of s plus beta y of s. The time-shifting property is also very similar. Again, we take the original transform x of s, but this time we multiply with e to the minus s times t0 instead of e to the minus j omega t0. Since we assume the unilateral Laplace transform, time reversal doesn't make much sense, because taking a causal signal or system and inverting time makes it non-causal, so that the unilateral Laplace transform is no longer suitable. But if we would use the bilateral Laplace transform, then the transform would be x of minus s. The time-scaling property of the Laplace transform is again very similar to the property of the CTFT. Instead of alpha times x of alpha omega, we now get alpha times x of alpha s. When applying the Fourier transform to the derivative of x of t, we got the original x of omega, but multiplied with j omega. Now for the Laplace transform, we get s times x of s, but we have to subtract small x of 0 minus, which is the value of the signal in time domain just before 0. When integrating the signal x of t, the Laplace transform is x of s divided by s, similar to x of omega divided by j omega plus the extra term for the Fourier transform. Since the Laplace transform is a function of s and not of omega, we have to adapt the frequency shift property slightly to get that for x of s minus s0, which is a shifting in the s domain, corresponds to multiplying the signal in the time domain with e to the s0 t. Similar to the properties of the Fourier transform, a multiplication in the time domain is a convolution in the s domain, but this time multiplied by 1 over 2 pi j. And if the signals x and y are convolved in the time domain, they're multiplied in the frequency domain and also in the Laplace domain.